Hello, this is John Linford from Paratools. In this tutorial video, I'm going to show you how you can use MPC to compile and run the Parallel Ocean Program, or POP. MPC is a multiprocessor computing framework designed for large clusters of multiprocessor or multi-core NUMA nodes. The core idea behind MPC is that you can take codes like MPI or OpenMP and recompile them to use user-level threads that hopefully give you better scalability and lower overhead. And it's been used successfully by the French Atomic Energy Commission, CEA, and other organizations around the world. If you go to the website mpc.paratools.com, you'll see a tutorials tab up here. Go to the tutorials page and you'll find a growing number of tutorials. The one we'll be doing today is the Parallel Ocean Program POP. If you click on this link, you'll be able to follow along with what I'm doing more easily, or you can just watch the video. POP is a great example application because it's found in industry, research, competition, and academic settings. You might find POP in another tutorial or even at supercomputing at one of the cluster challenges. This video was generated by American and Japanese researchers running POP at very high resolutions on the Japan's Earth Simulator supercomputer. The executable we're going to produce through this tutorial could be used to generate something similar. I'll be going through the steps of the tutorial in the same order as shown on the website. First, we'll build NetCDF using Intel compilers. Then we're going to build POP using the MPC compilers, which are really wrappers around the Intel compilers. And then we're going to launch POP on a single node using MPC run. And then finally, we're going to conclude and show you how you can download pre-built executables if you just want to jump to the end and get the build product of this tutorial immediately. We'll begin the tutorial by building the NetCDF library with Intel compilers. NetCDF is a popular data format, and POP uses NetCDF for its input and output files. Now, if you are in a high-performance computing environment, for example at one of the national labs, there's a good chance that you already have a NetCDF library that is compatible with MPC and Intel 14 available to you through one of the modules. However, if you're on your workstation or laptop, even if you have a Linux distribution, it's likely that your NetCDF library, if you have one, is not compatible with Intel 14 and MPC. If you don't know, or if you're sure that you don't have this library, it really just saves a lot of time to build it from scratch right at the beginning, and it's not very difficult at all. I've allocated an interactive node on one of Paratools' compute resources. I'm going to start by making a directory that I can work in. I'm going to build the POP source code and the NetCDF code here, just kind of keep everything organized. For my own convenience, I'm going to call this place popdir and put it in my home directory. Now I'm going to download the NetCDF base release. Now, by default, NetCDF doesn't support Fortran. You'll have to download a second package. But to build the Fortran support, you need the base release. So let's start there. You can get the NetCDF base release directly from the website, or you can wget from this URL directly. So I'm going to cheat a little, save a little time. You see we've downloaded a file, netcdf-4.3.0.tar.gz. This is a compressed tar archive, so we can decompress this with the tar command. You see that we've created a netcdf-4.3.0 source folder. I'm actually going to rename this folder because I'd like to use the netcdf-4.3.0 path as my target path for all NetCDF libraries. So I'm just going to call this netcdf source and go to that folder. The first thing we need to do to build NetCDF with the Intel compiler is set our C compiler. We do that by setting the CC environment variable. You can see which version of ICC I have here. You see that I'm using the Intel 1400 compilers, so fairly recent. Now we can configure netcdf by running the /configure script. And I'm going to give the prefix as pop directory netcdf 430. So you see now why we renamed the netcdf 430 directory earlier. I'm also going to disable netcdf 4. We don't need this functionality for pop, and netcdf 4 requires us to have the HDF5 library installed. You certainly could do that if you wanted to, but we don't need it, so we're going to save a little time here. Configuration will take a few seconds. You can see in the output there that ICC was used as the test C compiler, and it's working. So configure's completed. You can say make, and we're going to use a parallel make because I know that this node has 4 CPUs. We're just going to go ahead and do a J4, and I'm going to cheat a little and say install. So this is actually going to compile and install all in one step. And because of the -J4, we're using 4 make processes, so this will go a little bit faster than if you left off the J4. Okay, so netcdf was compiled. It was successful. And if we take a look at our pop directory, we see we have a netcdf-430 folder. We can look inside of there. We have a bin directory and a lib directory. Inside of bin, we have your netcdf utilities, and inside of lib, we have the bit that we're really interested in, the netcdf library itself. Now that we have the netcdf based libraries, we can install the Fortran release. So pop is written in Fortran, so we're going to need the netcdf Fortran to be able to link the netcdf libraries to pop. Download the Fortran release to your pop directory. So go to the pop directory, and you can either download the file directly from the netcdf website, or you can wget it from a URL. So here I've downloaded the netcdf Fortran 4.2 tar.gz. You see it here. Unpack it with the tar command. This creates the netcdf-fortran-4.2 folder. Again, we'll set our compilers to Intel compilers. By setting the FC environment variable, I'm setting the Fortran compiler. Set this to ifort. You can also set the F77 environment variable just to be safe. And one more thing we need to do is set the cflags environment variable to tell the compiler where to find our netcdf library headers, since we built these in a non-standard location. You do this by setting cflags to a capital I, popdir netcdf 430 include. Then you can just configure. Set your prefix to be the same, 430. So this is going to install the Fortran libraries in the same location as the netcdf libraries, using the header that we installed earlier at the pop directory netcdf-430 location. You can see from the output that ICC was used as a test compiler. You can see that ifort was used there, so our compilers are being set correctly. And the configuration we set for the base netcdf library should carry over to the Fortran libraries, so we don't have to do much more than just specify the prefix. Once you've configured, you can say a make j4 install. Now, if you know your system has 8 CPUs or 12 CPUs or however many, you can set that number here. Leaving the number off will set it to unlimited. That's not always recommended, but if you don't know, 4 is generally a safe number on most modern systems. This is going to compile the Fortran library. You can see ifort is being called. Just takes a second, and we've successfully installed the netcdf Fortran libraries. Now, if you take a look at pop directory netcdf 430 lib, you see we have some new libraries. We have a libnetcdf F, so two F's on the end there. That second F is for Fortran, and that's what you'll use when linking Fortran codes like pop. So now that we have the netcdf Fortran release, we can build the pop executable using MPC compilers. Go to your pop directory and download the pop source code from the Los Alamos website. Here you have it, climate.lanl.gov/models/pop. If you go to that webpage, you'll see a lot of information about pop, documentation, and so on. So we have the pop source code. We can decompress it and unpack the tarball with tar. So now we have created a new folder named pop. I'm going to go to the pop source code folder, and just to be safe, unset archdir. Archdir is an environment variable that pop uses when during configuration. Now there's no reason this variable should be set on your system, but just in case, if by random chance arch directory is set from something else, it can cause some unusual results, and it'll definitely look different from this tutorial, so just make sure that that is unset. Once you've unset archdir, you can run the setup run directory script. And the first parameter to set up run directory is just a folder name. You can pick any name, but I'm going to use MPC because that makes sense. All this does is creates a folder with whatever name you gave it, MPC, and copies some important files in there. You can go to the MPC folder. Pop has a custom build process, unlike any other application out there. It doesn't use configure or something you might be more familiar with. It actually uses these .gnu files that control the build process. So we're going to create a new .gnu file for building pop with MPC, and we're going to base it on this linux.gnu file. Copy the linux.gnu file to mpc.gnu to create the mpc.gnu. You can edit mpc.gnu in your favorite editor. I like VI. And the first thing we need to do is change our compilers. FC controls our Fortran compiler. We're going to change this to mpc_ifort to use the MPC compiler wrapper for the Intel Fortran compiler. In the same way, change the linker LD to MPC ifort. Change the C compiler to MPC ICPC. We're actually using the Intel C++ compiler, even though this is CC is generally used for the C compiler. Once you have the compilers set, you need to update your netcdf library paths. On the netcdf include line, set this to pop directory netcdf 430 include, and similarly set your link line to pop directory netcdf 430 lib. Go down a little further, you'll come to your C flags. So MPC, when you build an application with MPC, all processes in your MPI application become user-level threads. Now this creates some unexpected sharing, especially in global variables. Now in general, global variables are not a great idea and should be avoided as a part of good programming practice, but we recognize that that's often impossible. Now pop in particular uses global variables. And if we were to just compile pop without addressing the global variables, the user-level threads of MPC would begin to share those global variables in a way that MPI processes never would, and will cause pop to crash. So there are two things you can do when you have an application that uses global variables and you're compiling it with the MPC compilers. First is you can rewrite your whole application to avoid global variables, which is often not really an option at all, especially in legacy codes. Or you can try the -f MPC privatize option. This compiler option will automatically privatize the global variables so that each user level thread gets its own copy of the global. Now, there are a lot of things you have to consider, such as if it's a large structure, data structure, that privatizing it in this way might create a large amount of overhead, or there could be side effects that you didn't anticipate. So you might need to play around with this a little bit. For POP, using -fmpc privatize is all we actually need to achieve proper data protection. So add fmpc privatize to C flags. Also add it to here on fbase, which fbase will become the base options for our Fortran flags. So -dat fmpc privatize here. The final thing you need to do is update the libs line on line 84. We're linking the netcdf library -l in netcdf. We also need to link netcdf-f, the Fortran Fortran release for netcdf. You can see the changes we've made by comparing the linux.gnu file to the mpc.gnu file. Diff linux.gnu, mpc.gnu. So our mpc.gnu file, it works exactly like the linux.gnu file, which is a pretty vanilla compilation environment, except for we've changed our compilers to be the MPC Intel compilers. We've set the correct path to netcdf, and we've added the fmpc privatize flag to our C flags and our Fortran compiler flags. Now that you have the mpc.gnu file, there's just one more change we need to make in POP before it will work with MPC. POP is a Fortran code, and any Fortran application that's going to run in the MPC runtime environment needs to have its main program routine renamed to a subroutine called MPC_user_main. So to do that, we go to the POP source directory, which is in popdir/pop/source. In here, there's a file, pop.f90. Now, popf90 defines the main program pop. And you could go in here and you could find all the program.pops, there's only 2 of them, and change them. Or I'm going to show you how you can also do this with sed, which I think is a little easier. If you first, we're going to copy the main source code file to a backup file. And then I'm going to use sed to rewrite that file for me, a simple search in place, in fact, and create the new pop.f90. So I'm going to say sed expression search for program pop and replace it with subroutine MPC _user main. It's this is the important part. This is going to find every instance of program pop and replace it with subroutine MPC_user_main. It must be named this, or you'll get linker errors when you try to compile. So we're going to take this expression, we're going to apply it to the popf90 orig file, and we're going to send that edited file to pop.f90. Now you can see what changes are made by comparing the 2 files. If we compare popf90 orig to popf90, you can see that every instance of program pop has been changed to subroutine MPC user main. Or we could just open this in an editor and you see that where we had program pop before, it's now subroutine MPC user main. Now that we have an mpc.gnu file and we've changed the name of the program to a subroutine MPC user main, it's time to actually compile POP with the MPC compilers. So go to your POP directory, POP MPC, go back to the MPC folder. This is the place where we have our mpc.gnu file. The first step in the POP build process is to set the arch directory environment. So export archdir equals MPC. Now, archdir is part of the POP build process. It's completely unique to POP. It's has nothing to do with MPC. All I'm doing by setting this arch directory environment is I'm saying to use the mpc.gnu file in the MPC build directory when you go to build POP. So this is just a POP specific part of the build process. And then once you've set your arch directory, all you have to do is type make. Don't use the -j. Don't do that, because POP's build process doesn't fully support parallel builds. So if you use -j, sometimes it'll work, sometimes it won't. Just be safe and type just plain make. Compilation will take a little while. So I'm just going to skip ahead. Should take about 3 minutes. Pop compilation should succeed without any errors. So if you get errors, that's obviously a failed compilation, but a successful compilation doesn't print a success message. You'll know compilation succeeded by looking for the pop executable. So we have it right here. If you take a look at the libraries, the dynamic libraries that the executable depends on with the LDD command, you can see that we've linked in the MPC framework to this pop. So yes, MPC is actually being used here. You'll also notice that the netcdf libraries are not being found. So we're going to have to inform the dynamic linker where to find our netcdf libraries before we can actually run this executable. That's a pretty important part. So to actually run pop, the first thing you need to do is update your LD library path environment variable so that the dynamic linker knows where to find your netcdf libraries. This is pretty easy. Just export LD library path is $LD library path colon pop directory netcdf 430 lib. Just like that. Now it's important that you always include $LD library path on the right hand side of the equals. If you overwrite LD library path so that it only contains this part, then the MPC runtime won't be able to find the MPC runtime libraries and your code will fail to launch. Or, sorry, your application will fail to launch. So always append or prepend your netcdf library to LD library path. Once you've done that, you can again LDD pop. And now you'll see that the netcdf libraries are being found where we expect them. Home directory, pop, netcdf, lib, netcdf. So everything's there. It looks good. To run pop with MPC, we use the MPC run command. MPC run has a lot of options. You can see it by typing MPC run -- help. So the options we're most interested in have to do with the process topology. We're just going to use a simple topology of setting a number of tasks equal to the number of processes that you normally would use if you were launching this as an MPI application. So if you would expect to say MPI run np4 pop, in this case we're going to say MPC run in equals 4 pop, and this will achieve the same thing as an MPI run. You can see it pop takes off, runs through several iterations here, and it doesn't take long at all. MPC works really well. It doesn't incur a lot of overhead. Pop is successful. Pop ran successfully. So this concludes the tutorial of how to build and run pop with the MPC. If you go to the MPC website, navigate to tutorials, and go to the last page of the pop tutorial, this is tutorials pop step 4, you'll see that we have the binaries produced in this tutorial available for download. So you can download the netcdf libraries as built by Intel 14 compilers if you want to skip that step, or you can download the pop executable to, if you're having some trouble there, it might just be easier to download the pre-built executable, and then you'll be free to use MPC run and try it out. We also encourage you to contact us if you have any questions or you need any help, and you can even go to the website. If you go up here to the corner, click on login, you'll be able to create a new account on the website. Once you create a new account and log in, you can go to any page and edit the discussion page, which is a great way to ask questions about the content or point out if you have any, if you notice any errors or need clarification. We recommend that you just click on discussion right here. You could also go to the wiki and create new pages or get in touch with us that way. So thanks for participating, and we look forward to hearing from you. Bye.